Okay, good evening. Welcome to
Awesome Math number 137.
Awesome Math 137. So I had you playing around today for your homework with our continued fraction calculator.
Yep.
And why don't you show just some of the things you played with today and maybe some of the things you learned.
Let's see. We usually set it like that, and then we can set the number.
Okay.
So we did something like the square root of 17.
Okay.
And I looked what that was.
That's interesting.
It's around 4.
It's around 4. And do you know how to read what they're saying here? What that is?
It's 4 plus 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8.
Yeah, very good.
Yeah.
I'm going to tilt this down a little bit and even zoom in a little more. Okay.
Yep.
So that's what made you pick the square root of 17?
Well, I was doing some of them. I wanted to do some high ones and some low ones.
Okay.
Like I did square root of 65.
Ooh, interesting.
It's around 8. Then you could show the convergence for that.
Okay.
And then the convergence gone.
So we get 8. For square root of 65,
Yeah.
we get 8, which is a pretty good approximation to the square root of 65.
Yeah.
Then we get 129 over 16 is the next one.
Yeah, and then 2072 over 257, and these have no common factor.
Yeah, they don't have any common factor. Let me ask you something. Do you notice any interesting similarities between the continued fractions for the square root of 17 and the square root of 65?
Well, this is 4 plus 1 over 8 plus 1 over 8 plus 1 over 8.
Yeah.
Keep repeating. And it's 8 plus 1 over 16 plus 1 over 16 plus 1 over 16. So they're all powers of 2.
Interesting. Interesting. I wonder why. What do you think? What do 17 and 65 have to do with powers of 2?
Well, they're each one more than a power of 2.
Oh, they're each one more than a power of 2.
So it's 16 plus 1 and 64 plus 1.
Okay.
So that could be it.
Maybe. What do you think the next one that has this pattern might be?
Well, after 16, there would be maybe 26 would have it.
Why?
Because 5 to, it would be, then you need a power of 2, so it would be 33.
Ooh, okay. Let's check the square root of 33 and see if it has a nice, easy pattern. Because
So we could clear that, and we got, it doesn't really have that thing again.
So square root of 17 did, square root of 33 didn't, but square root of 65 did.
Yeah.
Huh.
Interesting.
Where
Well, I
else
did
could we
find
look?
a really good one for the square root of 2.
Oh yeah?
Yeah.
What was it?
Well, what I did the square root of 2, and then I did this one. It was a really good approximation. It was like 2.000000001.
When you squared it?
Yeah.
That's neat. That's neat. So that's interesting. Look at the convergence for this one also, because 2 is a power of 2, right?
Yeah. So we could try. Well,
This one, 1 and 2's.
Interesting.
4, the square root of 4 would just be 2.
Just
8, maybe. But we were actually looking for 1 more than a power of 2. Oh, but 2 is 1 more than a power of 2. It's 1 more than 1.
so it would work.
Huh.
It's a power of 2 and 1 more than a power of 2.
And 1 more than a power of 2. Maybe.
Cool.
Interesting. So 17 worked. 33 didn't.
And-
65 did.
And now
What would be the next one after 65 that's 1 more
65 will
than a power of 2?
It would be 128 plus 1 is 129. We
Want
can
to give it a
check
try?
square root of 129.
Maybe that has a nice pattern.
We got- It's 213161. 222.
Is that a nice pattern?
Not really.
Not really, huh? It's interesting. Well, maybe we should just check 1 more and see if it has a nice pattern. What would be the next one after 129?
Well, 256 plus 1 is 257, so we could check the square root of 257. look at it's 16 and 32, so maybe they like alternate.
Hey, yeah, what's going on here? Some of them have really simple continued fractions.
And some of them have really complicated ones.
Huh. Interesting. Pretty neat, surprising patterns hiding in these continued fractions.
Yeah.
Pretty cool. Anything else you want to say from what you learned today?
Not really.
Playing around with this?
Yeah.
Did you like it?
Yeah.
Okay, cool. I'm glad. All right, good job. High five.